I've heard so many ways that people try to boost their metabolism.
Drink green tea to boost your metabolism.
Eating spicy food makes you burn calories.
Our vitamin will speed up your metabolism.
Muscle burns more calories than fat.
Buy our metabolism boosting smoothie.
So start lifting weights today.
And lose weight easily.
It's all based on one idea, that there are hacks that claim to rev up your metabolism, crank up how many calories you burn, and the promise is weight loss. But people, that's not how metabolism works. I'm Dr. Jen Gunter, and from the TED Audio Collective, this is Body Stuff. I want you to forget everything you think you know about your metabolism. It's a complicated system, like really complicated. So today, we're going to talk about what we know about it, what we don't know about it, and the one thing that's nearly guaranteed to change your metabolism. I follow Dr. Kevin Hall on Twitter. I love following experts who can summarize really complex stuff up into very digestible bites, pardon the pun.
Well, I do my best.
He's a researcher at the National Institutes of Diabetes, Digestive, and Kidney Diseases, which is part of the National Institutes of Health, and he's an expert in metabolism.
Metabolism is the complex sequence of chemical reactions inside every cell of our body that harnesses the flow of energy and matter to basically create all that we are and all that we do.
So metabolism is every chemical reaction.
Every heartbeat that we beat, every flutter of our eyelashes is all driven by metabolism and energy. And not only that, but our heart and our eyelashes are also made of the substances that we derive from the food that we eat. We can't do without metabolism for 1 second of our life.
There are 3 fuels in the food that we eat: carbohydrates, fats, and proteins. Our metabolism has different chemical steps for each one. The result of that metabolic chemistry is energy to power you and nutrients that are used to build and maintain your body. The energy part of this equation is what seems to interest most people, especially those who are selling you products to hack the system. While some types of foods create more energy than others, the energy they create is all measured in calories. And to your body, a calorie is a calorie is a calorie. It doesn't matter what kind of food was broken down to make it. There are many techniques for measuring metabolism. Dr. Hall might use specialized equipment, kind of like scuba gear, to measure how much oxygen a person is breathing in and how much carbon dioxide they're breathing out, which lets researchers calculate the metabolic rate down to the calorie. When they perform studies, Dr. Hall and his colleagues invite a group of people to spend some time at the Hotel NIH. I'm obsessed with these NIH studies. It's such a fantastically cool idea to study what goes into someone's body and what comes out, all in a closed environment, so everything can be tracked. I imagine a 1970s motel, government budgets and all, in picturesque Bethesda, Maryland. I'd check into my suite, really a small room, where I'd spend the next few weeks sampling a curated menu prepared by the NIH's finest chefs. Look, the idea of having all my meals cooked for me and contributing to science, I'm in.
The chefs that we have are amazing, and these are what they call metabolic diets. They are not the typical sort of, oh, well, let's just whip something up that looks low carb. This is like everything is exacting to the gram.
So for example, they might make a 2,500 calorie diet that people will eat for 2 weeks, and it has to contain 95% protein. And then they have to come up with another 2-week diet with maybe 80% fat.
So it's not like they just have to design one meal. They have to design this rotating menu of meals, and we're trying to make them as as pleasant as possible, because the last thing you want to do is to have someone drop out of your study because they don't like the food.
I want to see like Iron Chef NIH edition, where you
Right.
have a team of a chef and a nutritionist, and they're each given like, oh, you have to have 32 grams of whatever this carbohydrate
Right.
and 5 milligrams of iron and this and that. Go and see
Go.
what meals you come up with.
And then they do chemical analysis of the meal at the end, right?
Right,
That's-
right. To see how accurate they were.
Yeah,
and
exactly.
They're judged on accuracy and how palatable it is and
Exactly.
presentation. I think I would totally
Exactly.
watch that show. The precision at the Hotel NIH shows Dr. Hall a level of detail that is essential if you actually want to know what is going on in the body. Much of his work uses one measurement, basal metabolic rate, the number of calories a person burns in a day to take care of basic bodily processes. We tend to think of our bodies using most of our energy for movement, exercise. But actually, the majority of the energy is spent on processes we don't typically notice, keeping our heart beating, building cells, digesting, or listening to podcasts. Our brains use a lot of energy too. Some estimates put it at 20% of our energy needs. So, do some people burn more calories with their bodily processes than others? Meaning, are some metabolisms technically faster than others?
I mean, there are certainly people who have a faster metabolism. Does it mean that people with a faster metabolism are protected from developing obesity? Well, not really. It doesn't look like there's much evidence for that, or that people with a slow metabolism are going to have a harder time losing weight than somebody else. It doesn't really look like there's much of a correlation there either.
So a faster metabolism is not at all linked with having a thinner body or vice versa.
It doesn't appear so. If you just look at absolute numbers, larger people will have a greater metabolic rate because larger bodies have more cells, their cells are doing more, and therefore they are burning more calories.
It turns out what has the greatest impact on metabolic rate is body size. In fact, Dr. Hall controls for body size in his studies. He accounts for it in the results. And once he controls for body size, the scientific difference between a fast metabolism and a slow metabolism, it only varies up to about 300 calories.
Very few people are kind of outside that range.
300 calories, if you're talking about that kind of like variation, that's like two bananas and an apple.
It's a small lunch, right?
Yeah.
It's not a huge amount of calories.
There are a few other factors that contribute to this range. There's age, which you obviously can't change. Your metabolic rate is different depending on whether you're an infant, a toddler, pregnant, an adult, and over the age of 60. It probably surprises no one that toddlers have the highest metabolic rate. They're busy learning and growing and moving a lot. But what about these metabolism hacks? The things we're told will change our metabolism so we burn more calories. What about, say, the keto diet? The pitch for the keto diet is that if you reduce your carbohydrate intake, like really reduce it, then your body will be forced to fuel itself mostly using fats. With keto, the rule is that only 10% of your daily calories should come from carbs, compared with the average American diet where they make up about 50% of your calories. If you follow this rule, you should enter ketosis, a process where your body breaks down fats to use as fuel. Keto advocates say that when your body is breaking down the fat in your food, you will mobilize body fat from your stores and also use more calories, causing weight loss. Dr. Hall, good metabolism researcher that he is, designed a study to compare a ketogenic diet, high in animal products but super low in carbs, with a plant-based diet with plenty of carbs but very little fat. His subjects moved into the Hotel NIH and followed one of these diets for 2 weeks. No matter which diet they were eating, everyone was getting the same number of calories each day. After 2 weeks, they switched to the other diet. Dr. Hall and his team were measuring each person's metabolism the whole time, and there was a slight difference on the animal protein plan.
Yes, indeed, people do burn slightly more calories, but again, we're talking about less than 100 calories a day.
Across several studies, Dr. Hall found a range from 60 to 150 calories. But to put that in perspective, 100 calories is one banana. It's a tablespoon of peanut butter. That's all. But remember, part of the pitch for keto is that the diet forces your body to burn fat stores, and therefore you should lose weight.
There's a conflation between fat burning and body fat burning. Okay.
Yes.
So what happens is that when you're eating a diet that's like 75% fat, go figure, you're burning about 75% fat. That doesn't mean that you're mobilizing fat from your fat cells in your body to produce those calories. It's a mixture of the calories that are coming from the diet and the calories that are coming from your body fat. And so at the end of the day, it ends up being the calorie imbalance that drives how much body fat you're burning.
Dr. Hall is saying that sure, if you eat more fats, your metabolism will burn more fats, but not necessarily the fat on your body. That's because metabolism will first use the available energy from what you're eating. It will only turn to stored fats if you're eating fewer calories than your body needs. So no, the keto diet isn't a trick for burning body fat. Dr. Hall has studied lots of different diets. He found that no one diet is really better or worse than another, with one exception: diets that are high in ultra-processed foods. Foods that are high in calories, fat, sugar, and salt, and low in nutrients.
In fact, that was the only diet that we've seen so far that causes people to spontaneously overeat when we test them at the NIH.
Dr. Hall doesn't know if the ultra-processed foods have some sort of effect on metabolism, but they did affect behavior. In the study, people could eat as much food as they wanted. When they were offered unprocessed foods, they ate slightly less than normal. But when they were offered ultra-processed foods, people consistently ate more than normal.
It turns out that the nutrients themselves are not driving excess calorie consumption. It's something else about ultra-processed foods, which we're hoping to figure out in the next few years.
I asked Dr. Hall about some metabolism boosters I'd seen online, like eating spicy food. I read some claim that spicy food would heat you up so you'd burn more calories.
Oh boy, yeah. This is the fun that people have when they try to see some extremely tiny and transient effect on metabolism. We're talking now tens of calories a day. And they extrapolate that to, oh, well, if we could just keep that up for 30 years and assume that the body doesn't adapt at all, then maybe this is a big thing.
Okay, this is important. Sometimes there's an effect in a study that is statistically significant, meaning researchers didn't think it happened by chance. But that doesn't mean it's clinically significant, meaning it may not have a meaningful impact on any person's life. And sometimes a tiny effect seen in a study gets blown out of proportion, particularly by companies that have products to sell. Sure, your body might spend a few extra calories today after a spicy lunch, but we don't have any data to say that would have the same effect every day for the next 30 years. Add in marketers trying to sell you products, smoothies, supplements, metabolic teas, and you end up with a whole collection of products supposedly backed by science that won't amount to any long-term effects. So no, you can't boost your metabolism. It just kind of keeps ticking along like a metronome until you have one of those life events, like being a toddler or getting pregnant, to change the beat. But you can slow your metabolism down, way down. Do you remember that TV show, The Biggest Loser? It was an awful reality show where whoever lost the most weight by percentage of their starting weight won $250,000. A lot of the show revolved around grueling hours at the gym. My biggest memory of it is of the trainers screaming at the contestants, often right in their faces. I mean, who does that? That isn't motivating.
I actually saw the last few minutes of the TV show. It is like the weigh-in, right? Where they make people take off their shirts if they're men. And it's just like this horrible fat shaming horror show. But the part that struck me was, people would step on the scale and the announcer would say, yeah, you lost 15 pounds last week. And I'm like, how is that even possible? Like that kind of goes against everything I've ever seen. And well, how many calories are these people burning with this exercise? And what are they actually eating?
Dr. Hall was fascinated. Here were people doing an extreme experiment on metabolism.
So I eventually found out the name of the physician who was in charge of the care of these folks. And I called him and said, hi, this is Dr. Hall from the National Institutes of Health. I'd like to speak with who's in charge of the clinical care of these participants. Anyway, I got this guy on the phone. He was an interesting character, and I was just kind of asking him, do you track how much they're eating? Do you measure their metabolic rate? Do you know how many calories they're burning? He's like, no, we don't know any of that stuff.
So Dr. Hall sent a couple of researchers out to California to evaluate the contestants of The Biggest Loser.
And you ask the question, well, was it the people who decreased their metabolism the most that lost the least amount of weight? And the answer is no, actually, they lost the most amount.
So I want to just restate that. So when you looked at the contestants of The Biggest Loser and you looked at the people who lost the most percentage of weight and they kept their weight off, they actually had the slowest metabolisms.
They had the greatest decrease.
The greatest decrease.
Like the metabolic rate was following whatever was happening during that period of time. It was a response.
6 years later, Dr. Hall checked in on The Biggest Loser contestants to analyze the competition's long-term effects. 14 of the original 16 contestants graciously participated in the NIH study, and all but one gained some weight back. But here's what surprised Dr. Hall when he looked at resting metabolic rates. The more weight a contestant regained, the more their metabolic rate increased. It rebounded in a way. People who kept more weight off had a slower metabolic rate, meaning they burned fewer calories at rest. This helps take down a myth that you can wreck your metabolism with efforts at weight loss. And Dr. Hall concluded that instead of metabolism driving changes in body size, perhaps metabolism is responding to something else. Next, let's find out how much activity affects our metabolism. For a long time, we assumed that our bodies ran like simple energy-burning machines. If you moved more, regardless of whether it was to run a marathon, walk to the grocery store, or hunt an antelope, your body would need more energy to keep you going.
We were sure that if you're really physically active, you're burning more calories.
Dr. Herman Poncer is an associate professor of evolutionary anthropology and global health at Duke University. He wrote a book called Burn. New research blows the lid off how we really burn calories, lose weight, and stay healthy. The idea that lifestyle had a massive impact on metabolism was so widespread, medical canon pretty much, that when Dr. Poncer applied for a grant to study it, he was initially told that it was unnecessary. Except some things didn't add up. He'd seen data from animal studies that made him question this canon. And there were gaps in the research too. Lots of metabolism research focused on the US and Europe, but much less looked at people with completely different lifestyles. So Dr. Poncer looked to modern hunter-gatherer communities.
All humans, we were all hunting and gathering up until a few generations ago, right? From an evolutionary perspective, 10,000 years is when farming starts. So up until 10,000 years ago, we're all hunting and gathering, maybe 12,000 years ago in some places in the world. And 10 or 12,000 years ago might sound like a long time to most folks, but to an evolutionary biologist, that's nothing, right? That's like yesterday.
He started a project with the Hadza, a hunter-gatherer society based in northern Tanzania. He hoped that in studying their lifestyle and metabolisms, he might learn something about how human metabolism evolved. They
have no electricity or plumbing, nothing like that. You're in the middle of a very living, very intact African savanna. You wake up in the morning, and women go out and gather plant foods, either berries or tubers. Men go out and hunt with bow and arrow that they make themselves. Women are walking like 8 to 9 kilometers a day. Men walk like 13 kilometers a day. If you're a step counter, women are getting about 13,000 steps a day. And some days are much higher, some days a little bit lower. Men are getting 19,000 steps a day. And that's not just like walking, to the bus. That's like, they're walking over hills, and women often have a kid on their back, and they're carrying tubers back home. And men are not just walking, but they're climbing up into these baobab trees to get honey. And, it's not, the walking is the most impressive part, but it's not the only thing that they're doing. It's so much else as well.
Dr. Ponser logged every activity the Hadza did, and he started measuring metabolisms. He analyzed data from 30 people.
It was a total shock because their daily energy expenditures, total calories per day, was the same as it is for people who are really sedentary in the US and Europe and all these other industrialized countries. So even though they get more activity in a day than you and I probably get in a week, even so, their total calories per day is no different than you and me.
That must have just been one of those like, okay, we got to run the numbers again. We must have done this wrong.
Oh, no, we assumed that we screwed it up.
Dr. Ponser says he double-checked his work. He measured metabolism in a different way and reanalyzed his results.
And it was the same answer. And so we're like, oh my gosh. And that made us feel like, okay, this is not only hugely surprising, but this is very real. And there's something here that we need to understand.
Remember, up to this point, we assumed that the more activity a person did in a day, the more calories they would burn. But the Hadza were doing way more in a day than people Dr. Ponser had studied in industrialized societies. And they weren't burning any more calories. The research seemed to show that metabolism did not work like a simple energy-burning machine. It was doing something way more complex, something that, on the surface, seemed to defy the laws of physics. Dr. Ponser developed a theory called constrained daily energy expenditure. The idea that human metabolism has a limit. Humans can burn up to a certain number of calories every day, and then they plateau. It made evolutionary sense.
So the way to think about metabolism from an evolutionary perspective is that an organism should spend as many calories as it can, but no more, right? Because there's always something useful to spend the energy on if you're an organism. You can always spend it on reproduction, or you can spend it on, these other tasks that actually evolution cares a whole lot about, survival and reproduction. On the other hand, you can't sort of spend more than you can get, because if you do that, then you're slowly wasting away, and that's not successful either. And so organisms should sort of be evolved to burn a particular amount of energy that they can dependably get. And the energy that we're evolved to burn is, that 2,500 kilocalories a day that we all burn. That's the human strategy.
Dr. Ponser called it a kilocalorie, but you and I know it as a calorie. So that's 2,500 calories a day, give or take a few hundred, depending on if you're a woman, man, or child. So how does your body limit its energy to a certain number of calories every day? Well, think of every process in your body like a list of chores. You only have so much time to complete them all. So maybe on the day you manage to walk to the market and cook dinner, you don't also manage to sweep the kitchen floor. In the same way, your body is prioritizing and reprioritizing its tasks depending on how much fuel it's got. In addition to energy that we use to breathe and move, energy is required to keep the immune system going, replace the lining of the gut, and make reproductive hormones, just to name a few. Your body juggles these tasks based on the energy that's available, and it can do it remarkably well for fairly extended periods of time without negative health consequences. So what are the energy boundaries? The Hadza men walk about 13 kilometers a day and are healthy. What about people who do even more activity than that?
One of the big challenges to this idea of constraint, energy constraint, is, well, how do you explain the Tour de France? How do you explain Michael Phelps? And that's a very fair point. And so we've done work on this. We actually, we were able to follow people who ran a marathon a day, 6 days a week. I mean, that's so outside my experience that's just blows me away.
This was a small group of men and women who were running regularly before the study began, living pretty active lifestyles by American standards. And then they ran or walked all the way across the country, from Huntington Beach, California to Washington, D.C. Dr. Ponser and his colleagues measured the runners several times throughout this marathon of marathons.
Well, the first week of the race, they're doing kind of what you'd expect. They're doing a marathon a day's worth of expenditure on top of what they were doing before they started running. But by the end, their bodies had found all sorts of ways to save energy. And they were actually burning, 600 or so calories a day less than they sort of should have been, based on the fact they're doing a marathon a day, right? So their body, even in that situation, their bodies are trying very hard to constrain and shave off calories where they can save them.
Put another way, your body might be able to overspend on its daily energy constraint for brief periods of time, but overspend long enough and the body may adjust. It finds ways to reprioritize its internal chore list so it has enough energy to cover extreme exercise. Dr. Ponser thinks that even the body's periods of overspending have a limit.
Would you care to guess what the highest expenditure is you can do for the longest amount of time? The most expensive, longest term event ever measured in humans?
The most expensive long-term event. Long-term event.
I'll give you a hint. It's 9 months long.
Pregnancy.
Yes. Yeah. So that's right there at 9 months is pregnancy. So our bodies are built to be able to maintain that for 9 months. But the point is that, yes, you can burn more than, the typical ceiling. You can go beyond that ceiling for a little bit of time. The longer you have to maintain it for, the lower that ceiling becomes.
Maybe that's why when it comes to ultramarathons, women can outperform men. But there can be consequences of pushing your body too hard in training for too long.
There is a cost to that, right? So you can do, it's called overtraining syndrome. And immune systems kind of crash and reproductive systems crash. Women stop cycling. Injuries take longer to heal. Illnesses take longer to get over.
Of course, most of us won't be attempting the Tour de France. In fact, many of us aren't getting enough regular physical activity.
And so our body is overspending on immune function. And we're overspending on reproductive function, and our hormone levels are actually much higher than they would be in a traditional farming or foraging society.
It might be tempting to think if exercise doesn't affect your metabolism, well, then why bother? But Dr. Ponser says that your body has evolved to exercise. We've spent the majority of our existence walking miles and miles every day to hunt and gather. Our bodies just run better when we exercise.
None of this work with energy expenditure with the Hadza or anywhere else suggests that exercise doesn't matter, right? The adjustments your body's making, that's a huge reason that exercise is so good for you. Basically, exercise gets everywhere and affects every part of your body.
All the data shows that exercise is generally associated with health and longevity. It builds bones, it strengthens muscles, it even helps your brain. I think it's really important for us to uncouple exercise from weight or metabolism. Exercise is something that we need in general. We need oxygen, we need food, we need exercise. And as for boosting your metabolism, well, you can't outsmart the genius of your body or your metabolic metronome. Next time on Body Stuff, what is sleep?
Well, the nerd answer is that we don't really know what sleep is.
From circadian rhythms to Puritan witches to the bat signal in your brain, we're getting to the bottom of sleep. Body Stuff is brought to you by the TED Audio Collective. It's hosted and developed by me, Dr. Jen Gunter. The show is produced by TED with Transmitter Media. Our team includes Mitchell Johnson, Ponce Rutch, Greta Cohn, Michelle Quint, Ban Ban Chang, Sammy Case, and Roxanne Hylash. Phoebe Wang is our sound designer and mix engineer. This episode was written and produced by Ponce Rutch and edited by Sarah Nix. Fact-checking by the TED Fact-Checking team. We're back next week with more Body Stuff. Make sure you're following Body Stuff in your favorite podcast app so you get every episode delivered straight to your device. And leave us a review. We love hearing from our listeners. See you next week.